And so we've kind of got an idea up now about what hormones are and then what organs make them. But one thing that confused me for a really long time is the idea of how much of these hormones are in our blood and how they actually get from point A to point B. And so I'll make a category for concentration. And my first thought when I started thinking about hormones are that these must be just kind of infinitely present in our blood vessel. There are an unimaginable amount of blood cells, and I just kind of categorized hormones with that level of red blood cells, just a ton of them flowing through our body. And while there is a wealth of hormones flowing through our body at any given time, it's actually a fairly small amount. You're talking about picograms per milliliter, which is 1/1,000,000th of 1/1,000,000th of a gram. So really small amounts. And I mean, let's say that the pituitary is wanting to stimulate the adrenal glands. It's releasing that amount of hormones, but it's not a straight shot. There is no straight shot to the adrenal gland. So it's really just dumping this hormone into the blood, and then it's going everywhere, almost like your body's showering in this hormone. And so very similar to radio waves, which are going everywhere throughout the air, but are only picked up by those that are tuned into them. The endocrine hormones are flowing all throughout your body, but their effect is really determined by where the receptors are located. And so when you have these autocrine signals, they're autocrine signals because the receptors are right there at the cell that are making them. And paracrine signals, they're paracrine signals because the receptors are pretty close to the cells that are making them. And the same thing with the endocrine system. That just means that their receptors are a really long distance away from where they're being made. And so that concentration, again, is small, but it's everywhere in the body, and it's being regulated kind of by two main ideas. You've got the idea of metabolism, that for every one of these hormones that actually reach its destination, 99% or so are actually metabolized by either the liver or the kidney, and the liver breaks these down and ultimately makes bile, and the kidneys breaks these hormones down and ultimately excretes them into urine. But for every one of these hormones that are being made, thousands of more are being metabolized and excreted in one way or another from the body. And so metabolism is affecting concentration, but secretion is also affecting concentration. And secretion affects concentration really through this important idea known as a feedback loop. And so I went ahead and pre-drew a feedback loop that I'll walk us through. And so the idea behind a feedback loop is that the products that are being made and causing that stimulation in different parts of the body also stimulate the cessation or the stopping of the production of the hormones themselves. So that's a little bit of a confusing idea, and I'll walk us through an example. So say we need more thyroid hormones, and our hypothalamus starts releasing thyroid-releasing hormones, which is how it communicates to the anterior pituitary that we need these hormones in our blood. The anterior pituitary then releases thyroid-stimulating hormone, which stimulates the thyroid's production of the thyroid hormones, like we talked about, T3 and T4, so triiodothyronine and thyroxine. So as these thyroid hormones travel through the blood, again, they're going everywhere in the blood, not just from point A to point B. They're in all of the blood vessels, and they're just bathing the body's tissues in these hormones. They eventually reach receptors on the hypothalamus and the anterior pituitary, which when that thyroid hormone is received, signals the anterior pituitary to stop the production. I'll draw that in red, so it's just really clear. It signals to stop the production of these hormones. And it does that in the anterior pituitary and also in the hypothalamus. It says we don't need these hormones anymore. There are plenty of it. And that's a really beautiful effect when you think about it, that the body is kind of naturally wired to not only elicit an effect, but also to kind of know when that effect is no longer needed. And so that's the idea of a negative feedback loop. And the negative feedback loop is the main way that secretion is controlled. And so you have these hormones, and you have these organs that are making them, and you have this idea of regulation. And ultimately, what that leads into is the endocrine system's involvement with the nervous system and behavior. And if behavior is just the coordinated internal and external response of our body in response to its environment, then we can see that the hormones that are signaling these effects in different parts of the body plays a pretty integral role in behavior. And then behavior ultimately forms the bridge between the physiology of the endocrine system and the psychology and the study of the mind, and how we respond in attitude and personality, and all of those effects that we talk about in behavior psychologically. The basis for those effects are the coordinated hormonal responses that are happening through the endocrine system. And so in this bridge between the physiology and psychology, that's where you start getting into ideas of cognitive behavioral therapy. And cognitive behavioral therapy is this idea that you can actually, control parts of what your body's doing physiologically with your mind. It's under conscious control, these little hormones. And so you can imagine that when you're really afraid, I'll draw like being really afraid there, that you have the epinephrine just coursing through your blood vessels, causing an increased heart rate and increased respiratory rate, and diverting energy away from your digestion and your immune system into this kind of fight or flight response. But that as you become conditioned to that fearful stimulus, and as you are no longer afraid of it, that you can actually become more consciously calm in that, and resulting in less adrenaline flowing throughout your body. And so this entire mass of hormones that are circulating through your body at any given moment are in some way under your control. And that's actually a pretty neat concept.